Good morning. I'm glad to be here today to present this very difficult topic of how to convert logs to lumber. And I just know that there's people in this audience that do this every day that have a lot to share that would be just as pertinent as what I have to share today in regard to stress relief and dimensional sawing. But we want to talk about sawing techniques this morning in this session that relate primarily to the way we use our Wood-Mizer sawmills. And so when we get into some of this and move along on stress relief and dimensional sawing, as well as grade sawing, I'm going to try to relate this more toward our customers versus a large industrial sawmill that is shipping trailer load quantities of wood, of sawn lumber each day, versus the small producer, someone who's running a Wood-Mizer and maybe producing 1,000 feet a day. I'm going to try to relate these aspects of sawing to our customer versus the larger commercial sawmill. So dimensional and dimensional stress relief. We're going to talk about dealing with the stress in the log, how a log reacts to being sawn. But first, this topic of dimensional sawing. Dimensional sawing is the sawing of construction lumber, primarily lumber that is targeted for size. It's targeted to be a 2x8, it's targeted to be a 2x6, it's targeted to be a 1x8, but it's a specific dimension so that it can be used in as construction material. And most of our owners are involved in this type of lumber production, whether it be for themselves, they've built their own home, or they're producing lumber, they are producing lumber for commercial markets. So most of our owners are taking logs and converting them to specific sizes, specific products to be used on specific projects. Dimensional sawing. And it demands, I think, a basic understanding of the structural properties of wood. If you're going to be producing lumber that your customers or you are counting on to hold the roof up over their head, I think you need to understand some of the structural properties of wood and how wood acts under load, how it acts when you point load it and you're asking it to hold a floor or a ceiling up, but you're going to put a piano up on that second floor. So we need to have a basic understanding of the structural properties of wood. And it requires the sawyer to know the best use for the species available. Some regions have ideal species for exterior siding, let's say. They have ideal species for floor joists or roof rafters. In other parts of the country, they would need to import species to be used for some of those applications. But each of you, in your given location, I think it requires you as a sawyer, when you're sawing dimensional lumber, it requires the sawyer to know the best use for the species that he has available to him. What would we choose to make our wall studs versus our floor joists, et cetera, and then decay resistance. What would we choose? What species would we choose to be the exterior, the siding, or potentially even the roofing material if you're using a wooden roof. So it requires the sawyer to know the best use for the species available, and it has the potential for a significant amount of overrun. And I bring this up just to say that the dimensional lumber business up our way right now seems to be paying the bills maybe even a little better than someone who's in the strictly sawing grade lumber. Hardwood grade lumber used for interior applications, let's say. The folks that are converting logs to lumber to be used for building materials have a much higher potential for overrun in that they are cutting the entire log maybe for one specific dimension. They might be cutting it all into 2x10s. Well, every 2x10 has the same value out of that log. When you're cutting grade hardwoods and they are graduated in value based upon their grade, then that log has a lot of different values in it. The wood in it would have a lot of different values. And so with through and through sawing, where you're cutting the entire log into, say, 2x10s or even 1x8s or whatever, typically you're utilizing the whole log and not having one portion of that log be worth much less than the other portions of the log. So through and through cutting can have a very high overrun on your log scale, and I'm convinced that it involves a high level of skill. If you're out there cutting lumber for building materials and you're doing it right, you are a skilled operator. You've invested in your equipment, you've invested in your education, and I hope that you're pricing these services or how you're using your mill to cut dimensional lumber in an appropriate way, recognizing that there's not a lot of people in our society that can do this and do it right. You are a skilled group of equipment operators. Does that mean because it requires a high level of skill that you can't attain those skills? No, that doesn't mean that. There are basic principles that are applied when we want to cut dimensional lumber for construction. There's basic principles that you apply to every log and how you saw it. You got to consider the source. You have to choose the right log for the job. I can't emphasize this enough, that there are some applications for a 2x6 white pine, and there are applications where it shouldn't be used, a 2x6 white pine, because of its structural integrity or its slope of grain. We're going to talk about knot placement a little bit. Choose the right log for the job, and then the knot placement. When a structural member is called on to span, let's say it's going to span and be a floor that's 14 feet wide, and we're calling on those structural members to hold the load up above that, hold that floor up. Well, when that member is put under load and it wants to break, it has to compress the top and tension the bottom of that piece. So knot placement becomes very critical. You see this knot right here, the larger knot that's on the edge of that board? That knot is going to have a drastic effect on that piece's ability to carry a load horizontally. Because when that member is loaded and we compress the top and tension the bottom, that knot that's on the edge really makes this piece, if it was a 2x8, it makes it a 2x6 or something less. If that knot is placed in the center of the board, there's what they call a neutral axis. We aren't asking the center of that board to compress, and we aren't asking the center of that board to pull apart. It's kind of neutral. So knot placement in a dimensional piece of lumber is very important. If you can get it in the center of the boards, you should be fine. If it's on the edge of the boards, it compromises the strength of that piece considerably. Doesn't mean it's a bad piece of lumber to be used someplace else, but it doesn't qualify well for a structural member or something that's going to be asked to span and hold a floor load or a ceiling load. Opening face considerations when we're cutting dimensional. It's simple, really. You've got to open a face. You're going to open a face of the log, and when you do, it's going to determine all four faces. So the things you want to consider are the knot placements. Is there a way I can position this log so that these knots will be more directed toward the center of the pieces versus the edge of the piece? Am I going to open this face so that I'm boxing the heart? on keeping the heart in the middle, and we're going to talk about that a little bit more as we move on here. But when you open the log, you do need to consider the position of the heart, and we're going to talk about that. Full cut or nominal. Now this temporarily right or temporarily wrong, that's a saying that I was doing a job for a fellow who'd had a fire. We were cutting lumber to marry in with lumber that had come from the store-bought lumber or lumberyard lumber, nominal sized lumber. And I said to Reggie, I said, well, gee, Reg, I'll cut these so that they fit right in with your store-bought lumber, but I'm going to have to oversize them a little bit. I don't want to cut them exactly the same size as your store-bought because we've got this shrinkage that's going to take place in the lumber that I'm sawing today. And Reggie said, well, then it's going to be either temporarily right or temporarily wrong, and he chose temporarily wrong. So when I sawed that lumber to fit in with his store-bought lumber, I sawed it 1 5/8 thickness versus 1.5 inches to allow it to shrink in, and therefore it was temporarily wrong versus temporarily right. And that's what Reggie wanted. I think that made the most sense. Full cut or nominal lumber, really in many situations I've heard of in our part of the country, is if you go to full cut lumber, the building inspectors will allow you to use it being non-graded. They know it's a 1/2 inch thicker, which gives you 25% more strength in just the thickness, and then it's wider also, being 7.5 store-bought, 8 off the mill if you're cutting 2x8s, or maybe 2x8s are even 7 1/4 now. But anyway, full cut lumber sometimes is acceptable when there's a question of whether the lumber needs to be inspected or not. Or they'll upsize you, where the job calls for a 2x6, you can put in a 2x8, and they will allow that versus having it grade stamped. Full cut or nominal, temporarily right or temporarily wrong. I think you get the idea there. So the technique is what we want to get at, the sawing technique for dimensional. And this technique, whole number sawing, the first point, is one technique that I've used a lot, and I imagine many of you in the room use this technique. You simply cut on the whole numbers, always. You're always making a cut on the whole number. Now, when you open your first face and you make a flat on the log, it's not important with that cut that you're on a whole number, but when you turn that log and you have a flat side down, you're on a whole number. And it doesn't matter if that number is 11, 10, 9, 7, 6, 15, 14, it doesn't matter, but you're on a whole number. And whole number sawing will always take you to one of the dimensions you're targeting. If you make a cut at 11, your next cut might be at 9. Your next cut might be at 8, might be at 7, but it'll always take you to a dimension you're targeting. What are the dimensions in dimensional lumber? 4, 6, 8, 10, 12. How can you miss if you always cut on the whole numbers? Now, it blends well with cutting what is needed versus yielding what you can. And when you're dimensional sawing, one of the worst situations to have is one dimension that you need and no other. Not all logs are going to be made to cut 6-inch material. So ideally, when you open a log and you're dimensional sawing, you need multiple dimensions. You need some 1-inch lumber. You need some 2-inch lumber. Or whole number sawing will give you 7/8 lumber or 1 7/8 lumber. And here's the deal with whole number sawing. How many of you saw that way? You always, when you're cutting dimensional. The neat thing about whole number sawing is that you're really going kerfless. Your 1-inch lumber isn't an inch. But you know what? Your plywood sheeting products and so forth today aren't an inch either. They're somewhere under 3/4 of an inch. But if you drop from 11 to 10 and make a cut on a Wood-Mizer mill, you're going to get a board that's a plump 7/8. It's going to be just slightly over 7/8 of an inch. Will that work as a sheeting product versus a store-bought product that's under 3/4? Works just fine. Your 2-inch stock. Well, if you're dropping from 8 to 6 and making a cut, you aren't getting a 2-inch thick board, are you? You're getting a board that's approximately 1 7/8. So is 1 7/8 good enough when the store-bought product is 1.5 inches? Well, I think it is. So whole number sawing and cutting what is needed versus yielding what you can are two techniques that blend very well together, because if you need some 1 inch and you need some 2-inch, if you cut on a whole number, that's what you're going to get. And it'll get you this other bullet point of getting them when you get there. Getting them when you get there approach. But whole number sawing, you always cut on a whole number. And cutting what is needed versus yielding what you can. Cutting all 2x6s out of a log or all 2x4s, I'll guarantee you, you are not going to yield that log as well as if you need multiple dimensions. You need some 4s, you need some 6s, you need some 8s, because all logs are not built to make you one specific product. And you're going to yield a lot better if you cut for yield versus the specific need. And I know you get on saw jobs and the guy says, all I want's 2x4s. And you know what? That's what you do. You cut all 2x4s. But if you're working on a pile of logs and they're your own logs and you got a project going where you may need some 1 inch and you may need some multiple sizes of 2-inch, that's the best scenario. And whole number sawing allows you to get to those dimensions. You'll always be at one of those dimensions or 1 inch away from it. Okay, whole number sawing. No fractions to figure. The only thing you have to do is on your last board, you do have to compensate for your kerf. In maybe your last 2 cuts, you might want to compensate for your kerf if you're running a mill that you're working right off the scale. If you have AccuSet on your mill, it'll do all the math for you anyway. But you will want to allow for the kerf not coming out of your last piece. So if your final cut is at 2-inch or 1 inch, that board will be plump compared to the rest of your lumber. So split it in half down to the bottom and nobody will notice it. Trim cut as you go. I think that's the way I deal with stress in the log the most. That using that technique of trim cutting as I go is probably the most common way I deal with stress in a log. So in other words, you're cutting and that log is reacting to every cut. So let's just say you've got a cant on there and you drop 2 inches and make a cut, and you recognize that that board that you're cutting is starting to lift on the ends. It's trying to lift on the ends and it's trying to do what we call face bend. Well, I assure you that the cant is also trying to move. In some cases, the cant will behave and won't move much at all. In other cases, it'll move a considerable amount. When you see that happening and you roll 180, what you're going to notice is that the ends are high and the middle is low. And it might be slight, or it could be a considerable amount. And you've got a decision to make. Do I cut another board knowing that my ends are thick and my middle is thin? Is it close enough for who it's for, close enough for what it's for? Or do I go right back where I was on that last cut and make a cut with that log having been rolled 180 degrees? If that log has been rolled 180 degrees and you cut right where you cut the last time, you're making a trim cut and you're getting those heavy ends off, and you're watching as that blade goes down through the log to see how much light is under the blade. That'll tell you how thin your middle is. So you've trimmed your heavy ends off, and you don't see hardly any light at all underneath the middle, and you drop down and you make that cut, and that board reacts and the cant reacts, and you may have to roll 180 and make a trim cut again. Yes, it's costing you lumber. You might better have it cost you lumber than a customer. There's no substitute when you're framing up a building for accurate lumber. You double your plates on the bottom and double your plates on the top. So the risk is that your walls are a different height, a considerable amount, if your lumber varies. So it's very important that your thickness remain consistent, that it's all the same, and that a builder can use it and calculate the height of his walls and so forth, because the lumber's accurate. He's stacking them on top of one another, potentially, for plates and sills. Rough cut is not the term I use to describe the lumber coming off our band mills. This is bandsawn lumber, and if the log behaves, our sawmills can cut just as good, if not better, lumber than you can buy at the retail outlets. And I hope you agree with that. Most of the lumber coming out of the retail outlets, they have maximized the size that can come out of that given log. In other words, if you see a skid of 2x4s, you look at the ends, look at the growth rings. There'll be a bunch of those 2x4s in there that have the heart right in them. Excuse me. There'll be some that they've split the heart. They've split it. But I'll guarantee you there's very few of them that came out of a log that was big enough to make a 2x8. It's only going to make a 2x4. So when you cut 2x4s or 2x6s out of much larger diameter logs, you are producing a better product, a much better product than you can buy at the lumber yard. And if you keep it accurate and do this trim cutting and take the measures necessary to keep it accurate, then you're producing lumber that's better than they can go buy elsewhere. There's several other characteristics of movement and issues that you have to deal with in lumber that are cause for concern. One of the things I've already mentioned, and that's boxing the heart. I think this is very, very important to cutting quality or good, usable, dimensional lumber. Doing it wrong, I have an ever-present example in front of me every time I walk down to the basement of my own home. My 2x10s that were floor joists, many of those, I did not box the heart, I split the heart. Well, not a lot of them, a few of them. And what's that member do when you split the heart? It does one of these numbers. It cups. If you leave the heart in one piece, it won't cup. If you split that heart and shoot for an even number of pieces, we'll talk about that a little more, and you split it, that piece will shrink like this and it'll cup, and it won't be the same height as the rest of your 2x10s. I can see it every time I go down cellar my own basement. What should I have done on that piece? Well, if you always shoot for an odd number of pieces out of that cant, that's the best chance you have of keeping a boxed heart, is if you shoot for an odd number of pieces. If you square to 12 and you drop to 10, 8, 6, 6 is what? That's the middle, that's the halfway point on 12. You can't make that cut at 6. I contend you're better off taking that 12-inch cant, drop to 11, make an inch board, roll 180, drop to 10, make another inch board, and now you've got an odd number of pieces and you can keep the heart in the center, and you won't be splitting the heart. Wood shrinks that way. It shrinks tangibly to the growth rings, and it will cup if you split the heart, and it's not nearly as good a piece as if you left that heart into boxed into one member. Box the heart, odd number of pieces, bow. Well, bow is simply a board that laying here on the floor, it may lay flat on the floor, but it bows. It's got some directional sweep to it. The difference between bow and face bend is if I lay the face bent board on the floor, it'll either be a teeter-totter with the center down and the ends up, or it'll be a springboard if you flip it over and you'll have the ends down and the middle up. That's face bend. Well, if you're cutting dimensional lumber, where are those defects the most undesirable? Bow, well, we were always told put a floor joist crown up. You almost expect a little bit of bow. A little bit of bow in a floor joist is fine. You crown it up. A little bit of bow in a roof rafter, that's fine. You crown it up. Start putting bow in a stud wall. And can you keep a straight wall with bow in a stud wall? Not if it's excessive at all. I mean, it needs to be kept very slight in a stud wall, bow. What about face bend? You're cutting a piece of wood and you see that the ends are trying to lift and the middle's staying down, the ends are trying to lift. Can we use face bend somewhere better than we can use it somewhere else? Well, I think so. Face bend for sheeting. If you nail one end of the board down and you nail the middle and on down to the other end, you can get it to lay flat. It'll lay flat for you. So face bend in some situations, if I'm cutting board and batten siding and I'm getting a little bit of face bend, I want my thickness to be the same, but if I'm getting face bend, not a big deal. If I'm getting bow and I'm doing board and batten siding, ideally a contractor or a builder wants to come up to the corner of that building, plumb his corner board in, and start putting them boards up one right after another, right? Try to do that with bow. Why, you're wedging and cranking and trying to push the middle, so you're fighting every board. It's a terrible defect to have in a sheeting application, whether it's your subfloor or your siding. Bow is a nightmare to deal with. Face bend's a little better. Twist, there have been times where I've cut a log with noticeable rotation in it, and I'm sure you have too, and every single board I had twist in it. You can't, I don't know a sawing technique that helps with a log that has rotation in it and the lumber wants to rotate as you're sawing. I don't know a sawing technique. But the only thing you can do is go short. Short lumber, you can, at least you can join one face and then put it through a planer and get a consistent thickness and maybe get the twist out of it. But these are all concerns, considerations when you are cutting dimensional lumber. Boxing the heart, I'm a believer in, shooting for an odd number of pieces. When is bow going to hurt you the worst? When is it totally unacceptable in a piece? Face bend. You know, when can I get away with some face bend and use it in a piece? Thick and thin should be non-existent. Twist is inherent in some logs, and I don't have an answer on how to deal with it. They're just, I haven't been able to conquer it. A little bit is okay in a sheeting product, I suppose, where you can pull the ends down just like face bend, but twist can be just about the worst, and I don't know how to saw to relieve it. Maybe there's somebody in the audience that does. So, stress relief. We've talked about trim cutting as you go as one method of dealing with the stress. When cutting multiple cants, stress relief is more likely to be needed. It's a log divided up into different pieces is kind of an illustration of taking a log, cutting it into multiple cants, and then cutting 2 or 3 pieces at the same time. You may be cutting 2 2x6s. You may be cutting a 2x4 and a 2x6. You might be cutting 3 2x4s. And you know, sometimes with large diameter logs, it'll work to cant that log out. and cut 2 or 3 members at the same time. Other times, when you drop down and make these cants, if this is a 6-inch wide cut here, that thing will take right off and it'll bow so much that you can't correct it. But there's other times when you cut it into multiple cants, it seems to relieve the stress, and if you oversize it a little bit, you can trim it back down to the dimension you're looking for and get along just fine because the stress has been relieved. In this stress relief method, there's some rules: cutting oversized cants, trim the cants, then saw your boards. And there's a rule that says if you're getting a moderate amount of stress, a 1/16 of an inch per foot of length to an 1/8 of an inch per foot of length, I think in most situations you're going to want that 1/8. You're going to want that 1/8 inch. So if you're looking for 4-inch cants, you would cut the 5-inch and trim it down, taking a 1/2 inch off each side if you're looking for a 4-inch cant. 8/8 is an inch, so you're going to be an inch over if you're 8 foot long. Oversizing and trimming down sometimes may be the only way. And now we're going to move into what we call best board or grade sawing. Now, what purpose or purposes do grades serve? Why is there this seemingly very difficult and precise way of getting to the grade of a board? Well, the grades were developed simply to direct the lumber to the appropriate market. If you look at cabinets, for instance, not a lot of long, clear lumber used in cabinets. If you look at hardwood flooring, it's pieced together, made from short pieces. A lot of the flooring is. There again, it doesn't require a lot of long, clear lumber or wide, clear lumber. So having grades is simply a way to direct the lumber to the markets where it needs to go. And it's a standard. Someone can say, well, I want lumber that meets this grade because of the way I'm going to use it. I'm going to make some long trim, long, wide crown molding. So I need clear, long lumber to do that. And they can order lumber by grade that'll meet a spec that they can use. Who needs to know? Well, I think it's important that if you're sawing lumber with these mills that you understand a little bit about grade. And if you're dealing lumber, selling lumber, and someone comes in and says, hey, I want 150 feet of FAS oak, well, you ought to know what FAS means. So I think it's, does that mean you need to be a grader? No. No, it doesn't. But I think you need to understand what the grades are if you're wholesaling or retailing lumber. If you're wholesaling by tractor trailer load, you better know the grades because you're going to be getting paid based upon your grade yield. If you're retailing, it's nice to know grade just in case somebody comes in your door that knows them. You're in the lumber business. He's a lumber buyer. I think it's helpful that you know something about grades and you can speak knowledgeably of the grades. There's 5 basic grades that the National Hardwood Lumber Association uses, 5 basic ones. FAS, they combined first and seconds years ago, and 83% of that board needs to be clear. That 83% has to be in specific sizes of clear wood, too, by the way. Number 1 common is at least 67% clear. Selects may have one face one side of the board that's perfectly clear, and the other side may have some defects. A one-face grade, a grade that you can imagine where there's a lot of applications where only one side of that board is going to be seen. So if the other side is poor, it doesn't matter. You can buy it on a one-face grade, But all lumber is graded from the poorest face. This one face grade is the exception. It's recognized as a one common back, but the side that's going to be revealed and used is the clear side, so therefore we'll pay a little money for it. We'll pay a little more money for it, even though the one side doesn't make the FAS grade, the one side does, and that's the side we need. So some buyers will buy on a one face grade. Selects is clear lumber also primarily, but the sizes are smaller. And then you got number 2 common, number 3 common, but the bottom line for grade is the widest, clearest. The widest, clearest pieces you can get. Time-tested tactics for sawing for the best grade. Again, here we are with this opening cut. Very, very important. After the first cut, the second cut determines the width of board you're going to get. So most people grade sawing will open up to a 4-inch wide face. If they're dimensional sawing, a lot of times they'll only open to a 6-inch wide face because 1x6 is the smallest pieces they need. But in hardwoods or grade sawing, typically you'll go a little narrower and look for 4-inch. Position of the knots is the opposite. You want those knots on the edges so that they can be trimmed off. And do we box the heart? Not usually. That's not a tactic that we use in sawing grade lumber. We look to make long clear lumber versus long poor lumber. So we cut parallel with the bark on the best faces, and we take the taper out on the low grade faces. Where there are visible defects, where you know you're going to have defects in the board, that may be the side you take some short low grade out to get rid of the taper, because the other side may be your long clear side. Parallel with the bark on the clear face, knots on the corners, and every cut affects 3 faces. If you're making a cut, it's also affecting the yield on the other 2 perpendicular faces. When you make a cut here, you're affecting the yield off of these faces because it's getting smaller. You may not be affecting the grade, but you are affecting the yield. Every cut affects 3 faces. So these tactics for getting the best grade for the grader's eye. I think Wood-Miser's a little bit different. We do some grade sawing based upon it's the best board for whom. Sometimes we might be cutting for width, a specific width versus a grade. Somebody may want red oak, wide boards to close in steel posts, make them look like beams or posts. In the ceiling, they may want to box in steel beams or whatever, but they want wide, clear lumber, and we may overlook some defects in a log and cut for width versus a grade. We may cut for color. Now, well, what do you mean cut for color? Well, there's several species. In grade sawing, I cut for color. Cherry's one of them. When someone's buying cherry, do they want white or do they want red? Cherry has a white sap ring. Typically, I'll trim as much of that sap off as I can because I know the buyer wants white or wants red cherry wood. He doesn't want white cherry wood. Some will mix some of the white highlights in, but typically they're looking for red. So we'll trim it off. In the retail mills that are cutting trailer, they don't care. They want the bark off. That's it. That's all the grader cares about is the bark is off. He's not going to downgrade it because of sap. Walnut, there's another one. What are they looking for, brown or white? They're looking for brown, aren't they? Ash, there's another one to cut for color. In the retail market, or wholesale market, excuse me, they don't care. It's ash, it gets run. Sometimes, in our grade sawing, we may cut for book match. Any of you do any of the book matching? Woodworkers just love to have a book-matched panel where the grain, is a mirror. The one board next to it is a mirror of the other board. Book matching. We may cut for specific widths We might cut specific widths for stair treads, let's say. We're going to make solid one-piece stair treads. That's what the customer wants. Grade's irrelevant, really. We're cutting for a specific width then. We got to make stair treads out of it. And then, where most of the grade lumber has to be 8 foot and longer, what about all that 4, 5, 6 foot lumber that's clear? That the woodworker doesn't need it any longer than that. It works fine for him. That's grade sawing, as far as I'm concerned. That's how grade sawing applies to us as Wood-Mizer owners. We're retailing small quantities maybe, and there's a lot of utilization that takes place in the short wood market because Wood-Mizer is a good short log mill. Short logs can be a nightmare on a standard carriage. So short high grade, that's a way that we grade saw. This seminar, this DVD, this session is really not the end all. It's just the beginning of information and techniques, advice, training opportunities that you can take part in. The NHLA short course is offered around the country, I believe, at different universities, different facilities, and there's a phone number for them. A book that you should have on your shelf, I think, unless you've just memorized all these things about wood. I still go to this book by Bruce Hoadley, and I've had that book 18 years. It's the Understanding Wood book that I would highly recommend. And then the Woods to Workshop by Gene Wengert, that we had Gene do that for us. That is one of the best, if not the best, condensed version of sawing techniques and handling sawn lumber that I've ever seen. That's a good one. I would recommend you get that Woods to Workshop, maybe even get it, call Wood-Mizer or check with someone next time you're ordering parts and see if they can send you a copy of that if you don't already have it. I appreciate the opportunity of having presented this seminar, and I hope that it's been helpful. And if there's questions at the end, I hope you'll ask them or stick around if we depart if you have questions. And thank you very much for coming today.